Okay, morning year 13. Sorry this didn't go on last night. It's going on first thing this morning, so it shouldn't make too much difference to you guys. Just some follow-up info on the second part of our video on fatigue and recovery. Now I've left some of the first stuff in so that you can, make reference to it. Think about that image that was shared in the last video clip, and also then the diagram about epoch, which we discussed in lesson, and I'm pretty sure that we're all happy about. We are going to talk in a little bit more detail about these two phases, so just bear that in mind. And then again about the oxygen deficit, which we should be really happy with now, and again just there finalising those little bits just to make sure that we're happy with this fast component, and then again the slow component. The fast component, like we said yesterday, we're talking primarily real emphasis on ATP and PC stores. We're looking at this taking sort of 3 or 4 minutes to fully restore, but within 50% of that's restored within 30 seconds and 75% within 60 seconds. Alright, so the fast component is primarily concerned with ATP and PC replenishment. Just make sure that we're aware that we're restoring ATP and restoring PC are slightly different things, so they would count as slightly different things on a mark scheme as well. I mentioned in the last video about myoglobin being created to be oxymyoglobin, and then you'll also get on some mark schemes you'll see reference to hemoglobin and oxyhemoglobin, which are also restored. So just be aware again of the difference there also. When we start thinking about the slow component, I've added some extra details into another slide, which you'll see as we go through the presentation. But this is primarily we're thinking about a much longer period of time, the removal of lactic acid and the removal of other waste products, and the return to our body's previous state. We know how lactic acid can be converted, how it's removed from the body, being converted into pyruvic acid and Krebs cycle of glucose or proteins. You'll also see that time scales there again, and this could, if you've done a really long piece of exercise like an Ironman or something like that, we could be looking at 3 or 4 days, if not more. Like I said, depends on the intensity and the levels of that. Now, just some additional details for you that weren't mentioned in the last video. The fast stage begins as soon as exercise stops. Alright, so the minute we stop exercising, we start recovering. And that's why, if you think about when you've done any running or anything else, immediately you start that recovery process and your respiratory rate is elevated for a short period of time. The slow stage, just to be aware of, that we're also thinking about glycogen and therefore carbohydrate replenishment during that stage. Our glycogen stores, those being replenished. Enzymes and hormones return to their resting levels. So think about the work that we've done previously and the role that enzymes play in our energy systems and their role within the muscle cells and such like. Under extreme circumstances during exercise, their activity is increased and different hormones are released, as we're aware. Those return to resting levels, and importantly we return to a normal or resting temperature, body temperature. So let's think about fatigue then. Fatigue is, and you'll see there at the top, a reduced capacity to complete work, and that's like the kind of textbook definition, and that is brought on by a lack of energy or oxygen. So you can think about energy in terms of any fuel or oxygen. Now you'll also see this phrase here, skeletal muscle tiredness. Now I'm not going to go into too much detail on this with regard to calcium ions, but what you need to know is that the leaking or depletion of calcium ions can lead to fatigue. That is sufficient for what you need to know to get to a mark. Just for the more curious amongst you, namely Matty, if you think back when we did our sliding filament theory stuff and we talked about actin and myosin and how they attach and work with one another, one of the elements of that is calcium ions that are within the muscle, and if they are reduced, and therefore there's not enough calcium ions, they're depleted or they've leaked away from the muscle, is just a medical term for that, then the actin and myosin are no longer able to attach to each other, and then that prevents a further muscular contraction. So if those actin and myosin can't attach, think back to the diagrams you've got, then that muscle contraction can't happen. Alright, so the calcium ions are just a part of that, but do not get bogged down in the detail of that. And then exhaustion can be physical or mental, and it's due to prolonged exertion or stimulation. Right, so exertion we're thinking physical, stimulation we're thinking mental there. This is important to you because this is commonly examined, the factors that affect fatigue. Alright, so the depletion of your fuel stores. Now, your fuel stores, depending on what we're doing, can overall be a lack of energy, but we've obviously got glycogen, we've got carbohydrate, and then we've got oxygen as a fuel store as well. A buildup of lactic acid or a change in the pH level. Now, think about what we know about what lactic acid does and how that can potentially inhibit. Once pH levels change, how that can inhibit enzyme activity. So that's the reasons behind that. Our hydration levels, which I'm not going to go into no many detail for because we've done so much work on hydration and dehydration. We know how that works. Insufficient rest or recovery. So if you haven't rested sufficiently or recovered fully from a previous piece of exercise. A lack of acclimatization, which again, we spent an awful lot of time talking about acclimatization, heat exhaustion, altitude, etc. And then the stimulation of pain receptors. So if we are experiencing pain, that then becomes associated with fatigue. You need to know this. You need to know this slide. So, is fatigue a physical or a mental thing? And I mentioned this to you briefly in lesson yesterday, that there's kind of two chains of thought. And traditionally, if we look at this here, it was thought that fatigue is a physiological response. And almost the things that we've got on the previous slide here about lactic acid and changing pH levels and lack of energy and such like were the reasons that we experienced muscular pain and then ultimately fatigue. Research now suggests that it's potentially a psychological response, and this is central governor theory. So again, this is something that you need to be aware of. If you think about the video that I showed you in the other lesson where we were looking at the guy with his bicep curl, and I was talking about the insertion point and how we saw his bicep basically tear away from the bone. I know it wasn't a particularly pretty video, but if you think about that, we never use all the available muscle fibers in a single contraction. So if I'm doing a bicep curl, I would not use all of my muscle fibers within my bicep to complete that muscle contraction. That's how the body works. That applies to everyone. One of the way that things were thought and the way that central governor theory came around is that if I'm not using all those fibers and then I start to get tired, so say I'm doing repeated bicep curls, I should be able to then recruit more fibers that are not being used, so therefore shouldn't be fatigued, to then continue to do that exercise. Alright, so do you follow that? So I'm not using all of my muscle fibers in my bicep, but if I continue to do a bicep curl, surely I can start to just recruit more of those fibers that are not fatigued to continue to work. And there is an element of truth in that. But the guys who that discovered central governor theory, a guy called Noakes, he found that that wasn't actually the case, that we didn't start to recruit more fibers. So there wasn't an attempt by the body to compensate for that. He found that that didn't happen. So what we've got instead is the central governor theory claiming that fatigue is an emotional response. Alright, so the central governor theory here controls the pace of the muscles to hold them back from the brink of fatigue, and that's because there's a threshold that is reached around the complete glycogen depletion, and the central governor theory claims that we never get to that point. Okay, so when that threshold is being reached, a distressing or a fatigue sensation is created, and this is kind of like a protective mechanism, almost what I talked to you about Golgi tendons and such previously. Alright, so this is basically designed never to allow complete glycogen depletion, so it holds us back from the brink of fatigue. So it's not actually our muscles that are telling us we've got to stop. It's actually a psychological, something that's happening in our brain. We'll talk about that a little bit more in lesson. Hopefully that makes sense. I've got a couple of questions for you on Friday, but you need to make sure you know all that stuff for then. Alright, good stuff.